structures in Rust are some of the most important things that we can work with because it allows us to, store data, but also, code that like implements and mutates and, gets that data all together into a single thing. But there's a couple different ways that we can actually do that. The first one that we learn about, especially if we're going through the Rust book, is just the struct. So, that's in where we just use the struct keyword. We create something. So let's do it. Say, this could be using like the example of like the final project where it's like an ECS system for, some game. It could be maybe like a struct for health. And maybe we have like data and it's going to be like a U32, let's say. Okay, that's great. Basically, this struct is its own unique custom type now. I can now use this when assigning to it. So to create this here, we can just do let player health equals health. And then when I'm creating this here, I have to then actually use the curly brackets. We'll say data is like maybe. Now, structs also allow us to give, methods attached to them to update them. And a lot of people might look at structs and then start thinking, well, this is just like object-oriented code, right? Because I'm sort of seeing this is almost like a blueprint for what's going to happen. It's kind of like a class. And to that, I would say yes and no. It's it does feel like a class. And if we use the impl keyword with a struct here, I can now create functions that are available, both private and public functions. So we can say pub function, let's say like new, and suddenly I have a constructor for health. That's kind of like a class. And we can use it as such as well. So let's just say new, we'll like bring in the data here. This will be a U32. And I'm going to return a self here. So I could just say, hey, I'm returning a health. And this absolutely works and is perfectly valid. However, I've noticed that the community tends to gravitate towards self with a capital S here. And this references to this type right here. So it basically just means that if I do have this, it's a little bit easier for me to copy and paste elsewhere and then use. And the tooling all seems to understand this and like know what this self is. For a while it was touch and go with like not really knowing. So if you're working with a very old version of Rust, or you for some reason you have like an old version of Rust Analyzer or RLS, you may find it just easier to just type in health in this case. All right, so let's now create health and auto return. And then here I'm going to use our brackets and we're going to put in data. Now I could just do data, I hit save. However, Clippy is going to yell at me saying, hey, I don't need to do this because in structs, when I'm defining these, if I have just like, key and then value and they're exactly the same thing, I don't need to actually do this. If you're used to ES6 in JavaScript and you know how, like you've seen this in that code, it's very similar. It's pretty much exactly the same thing. You don't need to have the extra colon and then same name if it literally is the same name. So this is how an alternate way that I could create the health. So let's do let enemy health is equal to health : new. And then let's pass in, you're also 1. So 2 ways of creating creating an instance of a struct. Now, this is like the equivalent of a static method. I call it with this : and off of the full health struct itself. We can also have methods that are attached to the instances of it. So I can run it like enemy health dot. So how would I create that? Well, pub function, again, these need to be public if I want to be able to run it out here. If I want to be able to run it anywhere within this info health, it can be private and I don't need the public keyword. So let's maybe let's do like you got hit, like we lose health. But let's like lose health. We'll call it like just lose. No, that's not nice. Lose health. Now I can't just say how much I'm going to lose health here for. Let's say I did that, it would be like amount, would be U32. I'm not going to return anything. And then, but now I don't have access to this data. Like I can't do anything. But if I'm going to make this a method that's accessible through an instance, I can add in another variable here, an argument, and just tell Rust, hey, this is going to be a self. Now, if I just read it self like this, the borrow checker is saying, hey, you're taking ownership of self. The entire instance is going to be consumed, and then at the end of this block, destroyed. So let's go ahead and we're just going to say, I want a mutable reference to self at this point. So now I have access to self, which is this data. So self.data, let's just do minus equal amount. So now here, let's just say we get hit. Well, the player attempted to beat the enemy hit the player. So we'll do player health dot lose health. Let's say like you lost 10. Well, I need to borrow this as mutable in order to run the mutable here. Mute. There. Okay. All right. So that gives us methods. If I want just a reference to health, so let's say like maybe something to like print our health out, it's like a pub function, like print health. We can just do a reference to self. I don't need to take anything in, and we're just going to do maybe like print line, and we'll just say health and self.data. And so just because the player got hit, let's go ahead and print both these out. So we're going to do a health.print health. Now, if I run this, we can actually see our health is 90 here. Okay, great. So that's a functions with just a reference. Now let's say I wanted to have something like inside and just like a private function. If I just did that one, let's do like I don't know, like lose everything or like reset maybe. Reset. This takes in a mutable reference to self, and just maybe sets self.data equals 100. If I try to run this on here, like player health.reset, actually, I think it's going to allow me to do this here, is it? Let's do another print health down here and see what it says. Oh, it actually let me do that. It lets me do that because it's in the same file here. And like everything is like actually accessible. If I have the health in a completely different module, then I won't be able to do this at all. It would need to be public for it to be accessible outside of this. So it is something like sometimes having your structs in the same file as where you're doing the examples can cause weird little issues like this. But I'm not gonna leave that in there. Okay, so that's normal structs. We have a couple different types of structs. Let's say we want like a speed struct, and I don't like need to do like this entire data here. In fact, let's just refactor health to be like a different type of struct because I'm only storing this one data here. It doesn't make sense to just say data like this. So I'm just going to get rid of you, and I'm going to turn this into a tuple here, where it's a U32 inside. Now, if this struct is in a different file, I'm going to absolutely need to mark this as public here. And the compiler will let us know, like, hey, you didn't make this public. So in order to access this, and in order to even set it, you're going to need this to be public. Okay, so we can still impl health. Notice now that I'm getting this error here, and that's because we need to have a semicolon whenever we're doing this type of struct. So let's refactor this. Health, when we're creating this data here, it's just going to be health tuple, like open close parentheses, 100. Notice that this is not a function. I am not calling health. It's more of like tuples are defined as parentheses with data inside of it. Now, if I want like multiple things, I can add multiple things, each with different types, and that is perfectly legal. Although note that when I try to use this, it's now needs both things in here. Okay, so let's now refactor this to make it work with everything. So new takes in the data, health, well, that's just really, I'm just actually gonna say self data. That's fine there. For this, now how do we access it? Well, to access inside of a tuple is .0 for the first item, .1 for the second, and so on. So I can just do self.0 and we're good to go there. And for this print, it's going to be the same thing, self.0. And that's a tuple struct. It's actually really nice. If you're wrapping data around something and you want to be able to access this, then it's super, super nice to sort of like just use that. It's easy. Now, there's a little trick that we can do with this. Let's say that I wanted to extract out of here, and like maybe I just want to be able to do like a dereference self like this. I just want to just dereference it, and I have access to to this U32. Well, what I can do is I can implement deref manually for this this struct type, and it's really, really, really cool when we do this. So let's do an impl deref for health. I'm using Rust Analyzer, so I can just do a control dot in VS Code and implement missing members, and it will auto write almost everything that I need, and I just need to fill out what this is. So what is our target type going to be? Normally this would just be self, right? It would be whatever this health is. However, I'm going to say that you are a U32. So now I'm going to have a reference to self target, well, this U32 here. So then I'm just going to write a reference to self.0. So now, when I dereference you, you are health doesn't. If I try to dereference now, it's going to be want that to be debug mode. Let's see, is that true? I don't want to derive that. No, I want to dereference self to have access to like what this number is. Oh, you know what the problem is? I don't think it actually knows what number it's going to be. So I think if I just do like let, this is going to be like health is a dereferenced self. It still thinks that it's health, even though when I deref it, it's now like this U32. So bear in mind that sometimes it gets a little bit confused with what actually is going to happen when you deref it. If I deref it again, I get the U32. So deref once, and I got rid of that's what was happening. I had to deref twice. So deref once, I got rid of the reference and I got like the health in memory. Deref a second time, and I get the U32 inside. That's what's actually happening. And now this print line will work exactly as expected. Okay, that's the second type of struct. Now the third type that I have written up here is an anonymous struct. And this is often used with enums. So if I have like an enum, I don't know, like one of different things that could be happening here. Let's do like people, or maybe like a favorite food. Favorite food. And so we can have like some people, like you only have one favorite thing. That's why it's an enum is perfect for this. So we can have maybe like we can have like a hamburger, hot dog, very, very American, I know. But then like ice cream, right? Well, the problem is ice cream, what if we have like, we have different things in here, right? So ice cream is actually going to be a struct here. And now I can put key and values into this. So, and ice cream, maybe we have like a topping that's going to be maybe like a string. We can have like scoops, which is a U32, like the number of scoops. And we can have maybe like flavor, which is another string. Each of these types could be, of course, like, you know, it could be another enum inside of it. We can go like, you know, very complex with our types. That being said, this is an anonymous struct. It's an example of that. And whenever you need to create an enum, but then you're like, I just need like more data. I just need to make it a little bit more complex. A struct, an anonymous struct can help out with that quite a bit. And then constructing this is probably exactly as you might expect. We can just say let favorite food. So this is going to be our ice cream. So ice cream can be equal to favorite food, ice cream, and then we're going to put in whatever that is. So we know we're just going to fill the struct fields out here. Topping, this is a string, right? So it's going to be a, I don't really use things in like toppings. So I'm just going to say nothing to owns. Scoops, I don't go for too many scoops anymore. I used to like get as many as possible. I'm probably just like a one scoop person. And flavor, let's go with like, I actually go back and forth. I think the last ice cream that I got that was like actual real ice cream that I liked a lot. There's an ice cream place here in Denver, and it has, what is it called? It's a Space Junkie. It's super, super good. And we'll just do a 2 owned for this as well. And this is perfectly legal code and allows us to create a struct that's anonymous that I can now create here. Now, of course, with anonymous code, I have to like fill out all these fields myself when I create it, unless I did an impl, but which is perfectly legal. You can definitely do that. So with that, I hope that that this helps out with like understanding how to use structs, what we can use them for, and how to create them. And I'll see you in the next video. Bye.